All right, welcome everybody. Today we are going to be solving cube root and 1/3 power equations. So we need to, we're asked to solve each equation. It does give a little hint here. It says no need to check for extraneous solutions as the domain for cube root functions is all real numbers. So we don't have to worry about checking for extraneous solutions. We did that with square root equations or half power equations, but you don't need to do that on these because you can have cube root of -8 and that comes out to -2. But you can't take the square root of like -16 and get a real answer. All right, so very similar to solving square root equations, you isolate the cube root here. So I'm going to take away 7 on both sides here on number 1. So we're going to get cube root of x plus 2 equals -2. And then in order to get rid of a cube root, you cube both sides. So you just end up with what's underneath the cube root when you cube a cube root. And then -2 to the 3rd power, well, that's going to be like -2 times -2 times -2, which is -8. All right. And now you just have a linear equation. You just get x by itself. And so you get x equals -10. Don't need to check the answer, okay? All right, number 2. These are 3rd power equations. What I like to do is rewrite them as cube roots. You don't have to do this, but it's something I like to do just to help me out. And yeah, either way, we're going to cube both sides in order to get rid of the cube roots. You could have also cubed both sides here, and you're going to end up with the same result. So it's just kind of your preference there. All right, so we're going to get x minus 3 and then 5x minus 7 here. Yeah, I was able just to cube at that point because we'd had 2 cube roots, but they were both just by themselves on each side. Just have a linear equation now, so we just have to get x by itself. So I'm going to go ahead and take x from both sides first. -3 equals 4x minus 7. Add 7 to both sides. We get 4 equals 4x, and then divide by 4. So 1 equals x. All right. And no need to check your answer. Hey, you feel free to check your answer, but you don't have to on these. There are no extraneous solutions. All right. Let me do number 3. Once again, I like to change this to cube root rather than a 3rd power. So I'm just going to rewrite it like that. You need to isolate that radical first. So we're going to divide by 2. And so we get cube root of x minus 50 equals -5. And now we're going to cube both sides. So this is kind of looking like number 1 at this point. So x minus 50 equals -125. Add 50 to both sides. And we get x equals -75. Okay? All right, and then number 4. That one, you don't really have to do any isolating. This is already isolated, so we're just going to cube this side. Ooh, look at this. This will be fun. We have to cube this x plus 1, okay? So that's going to be a little bit of a, I'll have to do a little work here. And basically what we have is this. Okay? So I'm going to go ahead and FOIL these first 2. And so we'll get x squared, and then we'll get a 1x, and another 1x, so that'll be 2x, and then 1 times 1 is 1. Okay, and now we're going to have to multiply that with this guy here. So however you like to do that, I sometimes like to do it a little bit more visually when they start to get this big. So I make a little box. And then here, x and 1 from the x plus 1, and then x squared, 2x, 1. So we'll get x to the 3rd, 2x squared. You're just multiplying, right, the rows and the columns here. X, and then this would be 1 times x squared, 1 times 2x, and then 1 times 1. Okay, just double checking a couple things here. I did that really fast. Yeah. All right. So now, usually these, if everything's in standard form here, which I did have, usually the diagonal terms combine. So I'm going to have x to the third, and then plus this would be 3x squared total, and then 3x, and then a 1. So now we have the x minus 5 here also. Now, wow, we have a cubic equation here. What I'm going to try to do, what you do with quadratics, right, is you move everything to one side. Well, cubics, usually the same technique works here. So let me just do that and see what we have on the next step here. So I'm going to get everything to one side. So we have 0 equals x cubed plus 3x squared plus 2x plus 6. Now pretty much the only way we know how to deal with this, we'll have to go back, hopefully you've studied polynomials before watching this video. So we need to think about how we solve this kind of thing. One way we can try to factor it is by grouping. So I'm going to try to factor by grouping and see if that works out. So that's where we take, we sort of group these in pairs, and we try to take out as much as we can from the first pair. Well, that would be x squared. And then we're left with x, right? X squared times x would be x to the third. X squared times 3 would be 3x squared. And then out of these two, I could take out a 2, and 2 times x would be 2x, 2 times 3 would be 6. Ah, that did work. If these match, then we can factor it by grouping. So then we can rearrange this sort of like this. We're taking out the x plus 3 out of both terms, basically. All right, then we have this, and now we need to figure out what would x equal. Well, negative 3 is going to be one of the answers, okay? And then, this one, well, if we're not really told in the directions whether we're considering imaginary or I should say non-real numbers, but let's just assume we are. I can tell this is going to come out to be something non-real, because if we sort of make a little mini equation asking, hey, how does this equal 0? If this, again, were 0, that would zero out the whole side, right? And make it equal to that side. So yeah, how could this factor here equal 0? So I'm going to take away 2 on both sides. So x squared equals negative 2. And then I take the square root, and yeah, I do have an imaginary number as a result. This is going to be positive or negative I root 2. So if we are considering non-real answers, then these are also 2 of the answers. We have positive or negative I root 2, okay? So really we have 3 answers, negative 3, and then we have positive I root 2 and negative I root 2, okay? All right, that was probably almost like a challenge problem, number 4. You're not going to run into that on number 5 and 6 below. Go ahead and do numbers 5 and 6 for some practice, but yeah, they will be more like numbers 1, 2, or 3, not like number 4, okay? Okay, so what I got on those, I got 724 on number 5. Just isolated the square root, cubed both sides, kind of got a big number here, and then take away 5 on both sides, and I got 724. Number 6, I just changed this to a cube root. Don't have to do that, but that's my preference. Divide both sides by 5, and then cube both sides, get rid of the cube root, and we end up with x minus 3 equals negative 8, and then add 3 to both sides, get negative 5. All right.